Hello students, this is Nilanjana Sanyal from My Math Front Online and ePorashuna. In one of our previous sessions, we have learnt about this term arithmetic progression. What do we mean by this term arithmetic progression? We know that if we have a series of numbers and if the difference between any two consecutive numbers present in that series is a constant, then that series can be termed as an arithmetic progression. And that difference is known as the common difference. Or in other words, if we add this common difference to any term of AP or arithmetic progression, we will be getting the next term of the series. So we know the speciality of an arithmetic progression. Now in this session we will be deriving the formula for finding the general term of an AP. And secondly, we will be solving some sums based on this formula. Okay. Now to find the general term or the nth term of an AP. N stands for n is any variable, is a variable which can have any value. N can be the 10th term, it can be the 100th term, it can be the 5000th term. So for an infinite series, we know that an AP can be a finite AP or an infinite AP. The series can be a finite series or an infinite series. So for an infinite series, n can have any value. Okay. So we will be trying to find the formula for getting the value of the nth term of an AP. Let us take up the series A plus B, A plus 2B, A plus 3B and so on. So it is an infinite series. A is the first term. Now we see that the difference between any two consecutive terms of this series is equal to B. See, if we take the first and the second term, and if we take the difference between these two terms, that is A plus B minus A, we get a B. If we take the second and the third term, the third term is A plus 2B, so A plus 2B minus A plus B will be giving us a B. The third and the fourth term, A plus 3B minus A plus 2B will be giving us a B again. So if we take the difference between any two consecutive terms, we will be getting the value as B. So this is the speciality of this series. So we can say that this series is an arithmetic progression. Okay. Now we will be trying to generate a formula for getting the value of the or the expression of the nth term of this particular series, which has the first term as A and the common difference as B. So A is the first term and B is the common difference CD of this AP. Okay. This series can be generated as follows. Now we have the first term as A and the common difference as B. Now how can we generate the rest of the terms? We will be seeing that. A is the first term and T stands for the word term and the subscript 1 stands for the first, the serial number of the term 1. So it is T1, term number 1. Now A can be written as A plus within bracket 1 minus 1. This first one stands for the serial number of the term, that is T1 or the first term. Since it is the first term, we are having 1 over here. 1 minus 1 multiplied by B. And we know that 1 minus 1 is equal to 0. So 0 multiplied by B will be giving us a 0, which when added to A will be giving us an A. which is the first term. Okay, so the first term can be written as a plus within bracket 1 minus 1 times b. Okay, now let us take up the second term. Second term is a plus b. How are we getting the second term? We are adding the common difference b to this first term to get this second term. A plus b will be giving us the second term, that is a plus b. This can be written as a plus within brackets. This 2 is signifying this, representing this second term. Since it is the second term, we are having 2 over here. Okay, it is the serial number of the term. And the minus 1 part is common for both the cases, and it is getting multiplied by b. So a plus is common, as well as the minus 1 and multiplied by b. All these are common, and this first number signifies the serial number of the term. We are seeing for the first and the second term, we are having this thing. Let us try to find the third and the fourth term as well. So the third term, a plus 2b, can be obtained by adding a b to this a plus b. The second term. Second term is a plus b. To this, if we add another b, we will be getting a plus 2b, which is the third term. And a plus 2b can be written as a plus. Now this, since it is the third term, 3 comes over here. And minus 1 and multiplied by b, all are common. Or everything else is common. This is the third term. Coming to the fourth term. A plus 3b. This is obtained by adding a b to the third term, that is a plus 2b plus b. And this can be written as a plus, since it is the fourth term, 4 comes over here. 4 minus 1 whole multiplied by b. So it is a plus 4 minus 1 whole multiplied by b gives us the fourth term, that is T4, and so on. Because it is an infinite series, it will be going on. Every time you see a plus is common, this minus 1 is common, this multiplied by b is common. Only thing that is varying is this first number within the bracket, and that is the serial number of this term. If it is the first term, we have 1. If it is the second term, we have 2. For the third term, we have 3. And for the fourth term, we have 4. Okay. Therefore, it is evident that in any particular term, the coefficient of the common difference is b. And what is the coefficient? This bracketed parts, these are the common difference of this, these are the coefficients of this common difference b. So the coefficient of the common difference is 1 less than the serial number of the term that we have seen. Is always 1 less than the serial number of the term. So the general term or the nth term of any AP with a as the first term and b as the common difference is equal to a plus n minus 1 into b. N minus 1 whole multiplied by b. This is equal to Tn. T stands for the word term, and n, the subscript n, stands for the serial number of the term. And since it is the nth term, we are having this n over here. N is a variable, it can have any value. Of course, a and b, these are also numbers, and n is also another number. So we can get the value of any term of an AP having a as the first term and the common difference as b. Okay, we have arrived at the general formula for the nth term of an AP, having the first term as a and the common difference as b. Now we will be solving some sums based on the formula. Example 1. Find the sixth term of the series 10, 7, 4, 1 and so on. So it is an infinite series. Okay. Solution 1. The given series is 10, 7, 4, 1 and so on. The first term we have learnt, we have got the formula using the first term as A, taking the first term as A and the common difference as B. So over here in this series we are having the first term as 10. So over here A, the value of A is equal to 10. And what is the value of B? The value of B is obtained by subtracting the second term the first term from the second term, or the second term from the third term, any two consecutive terms. It is the difference between any two consecutive terms in this series. So 7 minus 10 gives us a minus 3. 4 minus 7 is also a minus 3, as well as 1 minus 4 is a minus 3. So since the difference between any two consecutive terms is a constant, therefore we can say that this series is in AP. Okay. And since this series is in AP, we can apply the formula that we have found just now. Now we have to find the sixth term. So it will be T6. And T6 means n is equal to 6. Okay. Therefore, the sixth term equal to T6. Now, what was the formula? Let us just write the formula over here. Tn equal to A plus n minus 1 into P. This was our general formula. Okay. Therefore, the sixth term is equal to T6. And for A, we are putting 10 plus n is equal to 6. For n, we are putting 6 minus 1. And for B, we are putting minus 3. So this is equal to 10 plus 6 minus 1 is equal to 5 multiplied by minus 3. So if we simplify this expression, the multiplication should be done first. So 5 times minus 3 will be giving us a minus 15, and 10 minus 15 will be giving us a minus 5 as the answer. So the sixth term according to our formula is equal to minus 5. Let us check. Now, how do we get the successive terms? If we add the common difference to the previous term, we get the next term. So 10 plus minus 3 is 7, 7 plus minus 3 is 4, 4 plus minus 3 is 1, 1 plus minus 3 is minus 2, and minus 2 plus minus 3 is minus 5. So you see 1, 2, 3, 4, 5, 6. Minus 5 is indeed the sixth term of this series. So what result we have got is absolutely correct. And this is also the verification. We have verified our formula. On applying this formula, we have got the correct result. So our formula is correct as well. Okay. Now coming to example 2. Find the eighth term of the AP. They have given 3 terms and it is an infinite series as well. The first term is 1 by 7, second term is 5 by 7, third term is 9 by 7, and it is going on. Okay. Solution 2. Here A equal to 1 by 7, B equal to 5 by 7 minus 1 by 7. A is the first term. So A equal to 1 by 7. B is the common difference. This can be found out by taking the difference between any two consecutive terms. So 5 by 7 minus 1 by 7. See, the denominator is the same. Therefore, we have to just subtract the numerators. 5 minus 1 will be giving us a 4. Okay. We can take the difference between these two terms as well. If we take 9 by 7 minus 5 by 7, 9 minus 5 will be giving us a 4 by 7 as well. 9 minus 5 is 4 and the denominator is 7. So the difference will be 4 by 7. So the difference is common. It's constant. Hence this series is in AP. They have mentioned the word AP, but we can also verify whether this given series is in AP or not. Since the difference is common, is a constant, therefore we are having this common difference as 4 by 7. Hence this series is an AP. And we have to find the 8th term. So n is equal to 8. Okay. Now we'll be applying the formula. So T8 equal to A plus. So A is 1 by 7 plus n minus 1. N is 8. So 8 minus 1 times B. B is equal to 4 by 7. Okay. So we have 1 by 7 plus 8 minus 7 is 7. 8 minus 1 is 7 times 4 by 7. Okay. And these two sevens will get cancelled. This 7 is in the numerator and this is in the denominator. So these two will get cancelled. We will be getting a simple 4. That is 1 by 7 plus 4. Okay. Now we have to perform the addition. This is a fraction and this is a whole number. So we have to add these two terms. Therefore, the 8th term equal to 1 by 7 plus 4, which is equal to, since this is a fraction and this is a the whole number term, we have to take the LCM, and if we take the LCM, the LCM will be equal to 7 obviously, and the numerator will be 1 from this part, and 7 times 4 is 28. So 28 plus 1 or 1 plus 28 will be giving us 29 by 7. So the 8th term of this series 1 by 7, 5 by 7, 9 by 7 and so on will be equal to 29 by 7. We have not checked this answer, but you can verify it for yourself and see that whether we have got the correct result or not. Okay? Okay. Now let us take up another sum. Example 3. Find the number of terms present in the AP. 6, 8, 10, 34, and so on. Okay. Now, in the past two examples, we had taken two infinite series. Now, in this case, this is a finite series. We are having the last term. Can you see the full stop over here? It signifies that the series ends over here. 34 is the last term. Since we are having a finite series, therefore we can count the number of terms present in this AP. We cannot count the number of terms present in an infinite series. We can count the number of terms present in a finite series. And this is a finite series. The 6 is the first term and 34 is the last term. We have to count how many numbers are there in this particular AP. Is it in AP? Let us see. 6 is the first term. So 8 minus 6 is 2. 10 minus 8 is 2. So we are having the difference as constant. It is 2. We are having the common difference as 2. Therefore, this series is in AP. Okay. In this series, the first term is 6. the common difference b is equal to 2. And now we have to find the number of terms present in the series. And we are seeing that 34 is the last term, but we do not know the serial number of this term 34. So we are denoting it by the variable n, because we do not know the serial number of this term 34. So we are writing Tn equal to 34. Now basically we have to find the value of n. If we know which term is 34, we can say that many number of terms are present in the series. Okay. So our problem is to find the value of n, this n. Okay. We know that Tn equal to a plus n minus 1 into b. This is the formula that we have derived. So now we know Tn equal to a plus n minus 1 whole multiplied by b, and we are having Tn equal to 34. So we can, and we know the values of a and b. Okay. So in this particular expression, only n is unknown. And we know the value of Tn, that is equal to 34. So we can find the value of n by equating these two. So Tn equal to, in place of a, we are writing 6 plus n minus 1 into b is equal to 2, which is equal to 34. Now we will be solving this equation. Solving the above equation, we are opening the bracket. So it is 6 plus 2 multiplied with n gives us a 2n, and 2 multiplied with 1 is 2, and this is the minus sign. So it is 6 plus 2n minus 2 is equal to 34. Next, what do? We will be keeping this 2n to this side, and we will be taking the others to the other side. We have first of all computed 6 minus 2, and we have got 2n plus 4 equal to 34. Next, we will be taking this 4 to the side. So 2n equal to 34 minus 4, which is equal to 30. So 2n equal to 30. Now n will be equal to 30 divided by 2, that is equal to 15. So we have got the value of n, that is T15 equal to 34. Okay. So we have found that the number 34 is the 15th term of the given series. T15 equal to 34. Okay. Since 34 is the last term of the series, this is the last term, so the series ends over here. So we can see that there are 15 terms in the given series, because 34 is the last term and it is the 15th term of the given series. So we can see that there are 15 terms in the given series. Okay. So this is how we find how many numbers or how many terms are present in a finite series. Using this formula and equating the last number to this formula, we get the value of n, and we can say that that many numbers of terms are present in any finite AP. Okay. So just remember this formula, that is the formula for getting the general term or any term of an AP where A is the first term and B is the common difference. It is Tn equal to A plus n minus 1 whole multiplied by B. Thank you for hearing.